We're going to talk about multiplying and dividing polynomials. So a quick little refresher, if you're doing some long division, 3 won't go into 1, but it will go into 11 3 times. Then you multiply that back, which gives you 9. And then you subtract. I'm going to put in some zeros. And that'll get you 11 minus 9 is 2, and then 53. You repeat it. So 3 won't go into 2, but it'll go into 25 8 times. You multiply it back. 8 times 3 gets you 24. And then you subtract, which is going to give you 13. 13 divided by 3 is 4. 4 times 3 is 12. Subtract 1 last time, which will give you 1. 1 won't be divided by 3 evenly or at all, so you're just going to have 384 and 1/3. We're going to think about area for a minute because it kind of relates to multiplying polynomials. So I want you to see if you can come up with 2 different expressions that represent the total area of the big square here, and see if you can determine why they're equivalent to each other using some multiplication. Hence, you can think of it as 4 individual pieces or as one big whole, and think about the side lengths. Remember, area of a square or a rectangle is length times width. Let's do a little bit of multiplying. We have 3 binomials here that are being multiplied. I'm gonna think about which 2 would be easiest to multiply together first. If you look at these 2, they are 2 that are the same terms but opposite signs. So it'd be smart to multiply those together first because your middle terms will subtract off to 0 and it'll make your life easier. So if you multiply those, 3x times 3x is 9x squared. You get a 6x, a negative 6x, and a negative 4. So if you combine, like I said, those middle terms will subtract off to 0, and you just have 9x squared minus 4. That still needs multiplied by your other binomial, which I just realized has a typo. That's supposed to be 3x squared plus 4x, so I'm going to write it there like it's supposed to be. My 9x squared minus 4 needs multiplied times it. And then a little more distributive property, 3x squared times both terms in your second binomial will give you 27x to the 4th minus 12x squared. And then multiply 4x times both of them. It's going to give you 36x to the 3rd and a negative 16x. There are no like terms, but I'm going to go ahead and rearrange them because a lot of times polynomials we like to write in order from highest degree term to lowest degree term. Makes it easier to compare each other's values. So that looks good to me. Let's do one that has more terms. So if you look at this one, first off, there are 3 terms inside this. We have a trinomial, and the whole thing is being squared. You don't really need the parentheses around the p plus 2r, so I'm just going to go ahead and drop them off. And anytime you're squaring something, you want to multiply it times itself. So remember, you're not squaring individual terms, you're taking the whole expression times itself. So if I do that, I'm going to take 2 times the 3 terms in my second trinomial and get that. I'm going to kind of line things up as I go here. So when I take p times my 3 terms, I'm going to put my like terms kind of below each other. Get a p squared and a 2rp. And then my last one, 2r times all of that, is going to give me another 4r, another 2rp, and a 4r squared. Okay, you don't have to line them up like that if you don't like to, but I just kind of like to line them up. Adding my like terms together, I'm going to come up with this funky long expression that has 6 terms in it. Yeah, but that's it. Okay, so flashback to your Algebra 2 days. We're going to long divide some polynomials. A lot like your warm-up with the numbers. We're going to take my first term on the inside, divide it by my first term on the outside, which will give you 2m squared as the first part of your quotient. Then I'm going to multiply it back times both terms on the outside, which is going to give me 6m cubed plus 4m squared. Now I need to subtract off that result from my original polynomial. I'm going to go ahead and switch my signs here And then 7m squared minus 4m squared gives me 3m squared. And then just no like terms on the others are zeros, so they stay the same. My new first term gets divided by my original first term. So I have 3m squared divided by 3m, which is just going to give you 1m. Multiply it back times the outside is 3m squared. If those first two terms don't match, you're in trouble, double check. And again, subtract all of that. Be super careful with your signs. That's where people tend to mess up. So it's going to give me a negative 6m plus 2. Divide one more time. Actually, I'm not sure, but I think just one more time. Negative 6m divided by 3m gives you negative 2. And then multiply it back. Now, how do you know you're done? So if I subtract off that result, switching both those signs, I'm going to get 6. If you try to go and divide again, 6 divided by 3m is not going to come out as a polynomial. So if it doesn't come out as a whole number, that'd be 2 over m, so it's still a fraction. Then that means your last term that you're trying to divide is your remainder. So I'm going to have plus 6 over what I was dividing by, 3m plus 2, as my final result. One last sort of special case one here. If you happen to be dividing by a monomial, so a single term, then you could rewrite this as a bunch of equivalent individual fractions all over 2x. If you think about how like common denominators work, I could write this as negative 4x to the 7th over 2x plus a separate 2x cubed over 2x and so on and so forth, because if I was to combine those terms and they all have the same denominator, then it's going to be equal to my original. And then actually that makes things easier because I can do my division. Negative 4x to the 7th over 2x gives me negative 2x to the 6th, and then I'll have just a 1x to the 2nd minus 8 plus, and I can reduce that to 1 over x, and that's my final result. So if you have a single term in your denominator, this is helpful.